Today is May 2026, and what the United States Navy just deployed into the Strait of Hormuz is not a routine force rotation, not a scheduled asset replacement, not the kind of incremental repositioning that Pentagon press releases describe in language carefully engineered to avoid alarming the markets or the Gulf state governments watching every American military decision in this theater. With the intensity of nations whose economic survival is directly indexed to what happens inside a waterway that is 21 miles wide at its narrowest point. What just entered the operational environment of the most contested maritime choke point on Earth is a weapons architecture that has never been deployed in active combat conditions before. A combination of autonomous maritime systems, precision strike platforms, and layered aerial defense capabilities that fundamentally changes the tactical calculation that any adversary running threat models against American naval power in this region has to perform before it can reliably predict what happens when it moves against a United States formation. The Global Autonomous Reconnaissance Craft, designated GARC and manufactured in Maryland, is now conducting persistent combat patrol missions inside the Strait of Hormuz under Operation Epic Fury as part of Task Force 59's expanding unmanned surface vessel network. Autonomous vessels operating continuously through the most threat-saturated maritime corridor in the world, logging over 450 hours at sea in early operational integration, running surveillance patterns that no manned patrol boat crew could sustain without rotation, without fatigue degradation, and without the risk calculus that changes every tactical decision the moment a human sailor's life is on the line. GARC runs on the MAPC-2 autonomous control architecture, which handles mission planning, navigation, and remote control with an open software interface specifically designed to accept third-party systems and government-furnished equipment without requiring a complete hardware rebuild every time the operational requirement changes. It means the platform that enters the Strait of Hormuz today can carry a different sensor package, a different communications relay configuration, or a different strike payload 3 months from now without the procurement cycle that has historically made American military adaptation slower than the threat environment demands. What GARC introduces into that equation is a persistent detection layer that doesn't sleep, doesn't rotate, and doesn't require the command network to accept warning time measured in seconds rather than minutes. U.S. forces have now used in active combat 2 weapon systems that had never before been fired in a real operational environment. The Precision Strike Missile, known as PRSM, a Lockheed Martin ballistic missile compatible with the high-mobility artillery rocket system, and the low-cost unmanned combat attack system drone, designated Lucas. Lucas is a delta-wing drone costing $35,000 per unit, and its design is directly derived from Iran's own Shahed drone, the same platform Iran has been exporting to Russia and deploying against commercial shipping in this theater. Admiral Brad Cooper, commander of United States Central Command, described the logic in terms that left no room for diplomatic interpretation. The United States took Iran's own design, improved it, and fired it back at Iran. That is a message delivered in the most unambiguous technical language available to a military command. The aerial architecture above the strait is equally significant and operates on a detection geometry that fundamentally reshapes the threat environment for anything Iran launches from its northern coastline. Shipboard radar systems detect low-altitude threats at 20 to 40 kilometers due to the physical constraint of horizon curvature. An F-16 combat air patrol positioned at 150 kilometers altitude detection of the same threat extends beyond 100 kilometers, which translates directly into available reaction time increasing from 2 to 3 minutes at the surface to 10 to 20 minutes, with airborne radar coverage active. It is the difference between a single interception attempt with almost no margin for a second engagement if the first fails, and a layered, defensive sequence in which multiple interception opportunities exist before any threat reaches the vessels transiting the navigable channels. Three carrier strike groups are now operating simultaneously in this theater, the first time that has happened in the Middle East in decades, and the combined air wing those carriers represent includes more than 200 fifth-generation combat aircraft operating over a waterway whose total width compresses every Iranian launch platform, every coastal artillery position, and every dispersed fast attack craft staging area into a battle space that American sensors now cover with a density and continuity that no previous operational configuration in this theater has achieved. The 15,000 naval personnel active inside the blockade perimeter and the 50,000 total military personnel across the CENTCOM area of responsibility represent an American force posture that Admiral Cooper described explicum. Italy as a defensive umbrella extended across the strait to protect both coalition forces and commercial shipping. The submarine dimension of this operational picture requires its own attention because it establishes a precedent that has not existed in American military history since the Second World War. A United States Navy submarine operating in the Indian Ocean sank an Iranian warship with a single Mark 48 torpedo. That was the first American torpedo attack to sink an enemy vessel since 1945. A submarine engagement produces a warship that stops transmitting, stops moving, and stops appearing on tracking displays without any immediate indication of what ended it, from what direction, or from what range. The Iranian Navy command structure processing that event is now operating with the knowledge that American submarines are present, are authorized to engage, and have demonstrated both the will and the capability to use that authorization without warning. That knowledge changes every Iranian surface vessel movement calculation in every contested water in the region. The GARC deployment, the first combat use of PRSM and Lucas, the submarine torpedo engagement, and the three-carrier air defense architecture are not separate developments that happen to coincide in the same operational period. They are the sequential deployment of a weapons system integration that the United States has been building toward since Operation Epic Fury began on February 28, each component designed to close a specific gap in the threat coverage matrix that the IRGC's asymmetric doctrine was engineered to exploit. The autonomous surface layer covers the fast attack craft saturation problem. The airborne radar extension covers the reaction time problem that shipboard horizon limitations create. The precision strike systems cover the cost exchange problem that makes attrition warfare favorable to a force fielding $35,000 drones against multi-million-dollar interceptors. And the submarine presence covers the problem that surface naval dominance alone has never fully solved, which is the question of what an adversary command structure does when it understands that the water beneath every ship it moves is already occupied.